This is example 4 from notes 5.3. And here we're going to learn how to condense logarithms, which is a process of taking a logarithmic expression with multiple logarithms in them with the same base and writing it as a single logarithm. So the key is we need to have the same base, and then our goal is to just write log base something of one expression. It can be a complicated expression that may include quotients, products, and powers. So let's try the first example, 4a. And here we have the expression 4 ln z plus 3 ln z plus 5 minus 2 ln z minus 5. Our goal is going to be to just write it as a natural log of one expression. And we're going to do, it's this process of doing expansion in reverse in order to condense. So the first thing that we're going to want to do is take the coefficients that are out in front and move them back as powers. So we can write 4 ln z as ln z to the fourth. And then for the next one, we're going to have ln plus ln of z plus 5 cubed, bringing that 3 up to the power. And the coefficient of 2 on the last term is going to become a power, so it's going to be minus ln z minus 5 squared. The next thing we're going to do is to continue to condense. So when we have the sum of logarithms, that can become the log of a product. And when we have the difference, that's going to be the log of a quotient. So I'm going to take these first two expressions, and that's going to become ln of z to the fourth times z plus 5 cubed. And then I have minus ln z minus 5 squared. Now we have the difference of two logs. That's going to become the log of a quotient. So I have ln, and then I'm going to write a quotient because my goal is to just have one single logarithmic expression inside. One expression inside the logarithm, I should say. So it's going to be ln of z to the fourth times z plus 5 cubed. And then when I'm subtracting, that's going to go to the denominator because it's division over z minus 5 squared. And in general, if we have a bunch of terms that are added or subtracted, anything that's positive or added will be in the numerator. So here we have ln z, 4 ln z plus 3 ln z plus 5. Those terms are going to end up in the numerator, and the one that we're subtracting is going to go into the denominator. So that's the end of the first problem. Let's go on to the second one. Our goal, once again, is to write this as a logarithm of a single expression. So the first thing that I would do, I would begin by condensing inside the parentheses. So we're going to have 1/3. We have log base 3 of 5 plus 2 times log base 3 of x. So log base 3 of 5 I'm just going to copy down. But the 2 log base 3 of x by the power property will become log base 3 of x squared. Now we're going to continue on, and we're going to keep condensing inside the parentheses. So now we have the sum. We have the sum of two logarithmic expressions, and I can rewrite that as the log of the product. So this is going to become log base 3 of the product, 5x squared. And now we have this 1/3 out in front. By the power rule, that can become an exponent. So that's going to become log base 3 of 5x squared to the 1/3, which can also be written as log base 3 of the cube root of 5x squared. And we're finished because we have the logarithm of a single expression. Next problem. We're going to begin condensing. So we have log base 3 of x plus 1/2 log base 3 of y plus log z. And it's important to note that you can only condense logarithms with the same base. So log z is base 10, and the other ones are logs 3. So log z, this cannot be condensed, this particular term. So we're going to just leave that on its own. It has a different base. So I'm going to work with 8 log base 3 of x plus 1/2 log base 3 of y. The coefficients in front become power. So we're going to have log base 3 of x to the 8th plus log base 3 of y to the 1/2 plus log z, which cannot be condensed with the other two. And now we have the sum. The sum can be condensed as a product. So we're going to have log base 3 of the product of x to the 8th, y to the 1/2, plus log z. And if you like it better, you can write this as x to the 8th times rad y plus log z. I would be fine with either of those last two expressions. This last problem is an ACT-like problem, and we're asked which of the following is equivalent to this expression with the sum and difference of natural logs. So we have ln 8 plus 2 ln 5 minus ln 10. We want to condense this and see what we get. So the first thing we're going to want to do is take the coefficient of ln 5 and bring that up as a power. So we'll have ln 8 plus ln 5 squared minus ln of 10. And that's ln 8 plus ln 25 minus ln 10. Since these are constants, we can just evaluate them. And now we're going to continue condensing. So we have ln 8 plus ln 25. That's a sum, and that can become a product. And then we have also something that's subtracted. That's going to go into the quotient. So I'm going to write this as ln of 8 times 25, condensing the two terms that are added, and then minus ln 10 means I'm going to put the 10 into the denominator, doing that in one step. And 8 times 25 is 200, so this is the natural log of 200 divided by 10, which is ln 20, so the correct choice here is D.